Hello, I'd like to talk about stacks today. In the last video I did, I defined the stack and I gave you what was needed for the ADT. To remind you, a stack is a last in, first out list. Everything happens on one side. We could might think of it easily as a vector or an array. And the items we need are a push to put items on it, a pop to take items off it, a top to return the top value of it, and is empty to determine if it's empty. And is full, I don't think I will need. Now, as an example of this, I'm going to do the following. I'm going to have the input is a string. And the output is whether the parens, curly Q brackets, and square brackets are legally placed in the string. So, for example, in the string parentheses 9 plus a close parentheses s close parentheses, the parents are correct. In square bracket, oh no, that was brace, a x paren brace, there is a problem since we open the brace inside a paren, but we close it before we close the paren. So one problem could be that they're not actually nested properly. Another possibility is in this one, for example, we have a closed parentheses, but no open to match it. That is a problem that we can't allow. And I guess the third one that you might think about is in, let's say, brace 3, brace, we do not close one of the braces. So those are the errors that we could have when we bring in such a line. Now, how can we do this, and how can we use a stack? We will create a stack and look at the characters in the input string. Every time we have any kind of parentheses of this, but any of these, well, I shouldn't put it that way. Anytime we have an open parent, by which I mean that, or the brace, we push it onto the stack. Every time we have a close parent, that would be this, this, or this, we compare it to the top of the stack. If it is closing a parent of its kind, we pop the stack and go on. If not, we have an error. We are either in this case at the beginning here, where we mixed up, we closed the wrong thing, or we're in a case like this where we have a closed parenthesis and nothing to match it. So one way or another, we have a problem. Now, if the character is not a parent type, do nothing. So as an example of how this is going to work, let me put in as my string this, 9, hello, this, bracket, 3, bracket, 6, now, that's properly set up. The stack is going to go as this way. The first thing we'll see is we'll put the parent in. We'll then put the second parent in. So now we have the stack with 2 items on it. We ignore, I should say, we go by the 9, the spaces, the hello. We go right by them. We don't do anything. When we reach the close parent, we pop, get the top of the stack, and since it is a close and open parentheses, we pop the stack. So our stack now just has the 1 parent in it. The next step is we see the bracket, and we put it in. We go by 3 and spaces and get to the close bracket. Again, we get the top, and since it is the open bracket, we pop the stack. Now our stack just has in it the one item, the first parentheses we put in. Next, we get the closed paren, so that is there. We get the top and pop the stack because everything is fine. Now the stack is empty. Unfortunately, since it's empty, well, there's no unfortunate yet. Everything's fine until, of course, we read the last parentheses there. When we get the last paren, and there is no top, so we have an error. I hope I caught that in my program. I'm worrying in the program I might have forgotten that. But that's the way to do it. That's the algorithm. It just goes on and on like that. Now I have a program for this. Let me see. Here it is. I used a vector to implement the stack. I'm sure you're glad I didn't use a linked list. I could have used an array, but a vector doesn't limit the amount I can put in, where an array I'd have to choose some upper number. And I used string for the input since it was easier. Now here's my class. I called it myStack. I couldn't call it stack because there's a built-in stack and this would have interfered with it. The private section is the stack. I don't want anybody getting in there except through top, push, pop, nothing else. Then I'm going to have a very simple push, push back. I'm going to have a very simple pop. If it's not as empty, I'm going to have the vowels dot pop back. Boolean is empty. I just returned is the size 0. And I had top. If it's not empty, I return the vowels dot size -1. So those were my setups there. Now here's my program. myStack, pause for parentheses. Boolean error. String inval. And more will be Y, so I can put in more if I feel like it. And I needed an I for some things in here. While more equals yes, I will input an expression. Then I'll say there's no error in the expression right now. And I'll start at the beginning of the expression. So if I is less than the length of the string, and there's no error, then I am going to compare in I to each of these 3 open parentheses. If it is one of them, I push it on. If it's not, and this one was a little complicated, it probably could have been made easier. I I first check if in I equals the parentheses, and the pos is empty, or pos top equals the open parentheses. That's one case. Or I'm checking for the other case where I am looking at the brace, or I'm checking for the third case where I'm looking at the bracket. So each of those is only saying, if I have a close of some form of parentheses, then as long as, if I do not have the right open parentheses, either because the stack is empty or because it isn't there, there's something else there, then I'm going to print out that we have an error. I'm going to set error to true, and we won't keep going around. Else if it is one of these three, in other words, I now have the correct setup. I have one of those three, and I didn't have an error in finding the corresponding one. So now I have to pop the stack, as I said in the algorithm. And that's it. And if there's not an error, this is the last part, pardon me. If there's no error and the pos is empty, is not empty, I've got an unclosed type of parentheses. There's something there. Otherwise, I'm correct. And then I ask the person to go around again a few times. So this is very similar. I think it's what we had here. The last part of it I didn't put in, I guess, up here. When we reach the end of the string, the stack should be closed. It should be empty. Now that's in the book, but I think they do it in a more formal way. I thought that we could get away with doing it this way. So I'll bring that back up. You'll notice I have a class here. The problem with the class is it only works for characters. What if I want a stack of integer, or a stack of double, or a stack of string? Do I have to rewrite this entire thing? Well, it turns out no, because now I'm going to show you the homework 5 information that I sent to you, that I put out just earlier today. That didn't work, so let's just try it this way. And I have the program that's going to start it off. But before I do that, I have to explain what we're talking about here. We normally write expressions, numeric expressions, in what is called infix form. That's these items right here, these three. It means that the operator, the binary operator, is between the two operands it works on. That's why it's infix. But that particular method requires us to use parentheses. And when a computer is evaluating an expression, the parentheses cause problems. It would be better if there were no parentheses. So there have been two different ways of writing an expression that are equivalent to the infix, but make it so that the computer does not have to think about parentheses. One is called postfix and one is called prefix. I am using postfix in this homework. What postfix means is the operator comes after its operands, not between them, but after them. Over here we have 6 plus 9. Here we have 6, 9, and plus. So when the plus comes, we have the two operators. In this case here, we have 3 operands. What's going on here? Well, the plus is in front of the 2 and the 7. When we see the plus, we take these two operands, add them together, and then that's a new result. It would be 9 in this case. Then when we see this, the star, we multiply the 9 times the 31. Here, the same kind of thing. The plus 6 and 7 produces 13. The plus 9 and 3 produces 12. And then we do a division of the 13 by the 12. And then when that's over, we multiply 4 times whatever that is. I'm going to work entirely with integers, which means that the division will be integer division, not real division. Well, a stack is the way to do this. There's no doubt about it. But this needs to be a stack. You'll see this needs to be a stack of integer. So the input is going to be a string in postfix form. And we're going to allow plus, minus, times, divide, and exponentiation. Since we're allowing exponentiation, you're going to need the CMath include, because that's where you get the POW, the POW, which makes it possible to do exponentiation. Here's a technical word, a token. If you were taking a course in compiler construction, you would learn that when we put in code, the machine takes apart the code and creates pieces of it, which it calls tokens. A token is a meaningful portion, like it's an operator or it's a number. In this case, that it's one of those two. But it could be a key word if we were looking at more complicated situations. In our case, it is either the number, which is an integer, or the operator, which is one of those 5. Now, I will make a slight addition. I'll have a token that says we're at the end. We're at the end of the whole thing. So here's the method. Read the exponent. While you're not at the end of the expression, while you're not at the end of the expression, get the next token. If token is a number, push onto the stack. Else, it's not a number, so it must be an operator, because it's not the end. We're in a while that prevents us from having the end as the token. So we go to the stack and take off the first 2 items from the stack. And then we perform the operation and push the result back into the stack. When we finish, when we get the end token, the value should be in the stack. Now, I'm not asking you to look for errors in the input. I'm going to assume that the input is proper, that there's no problem. Well, this is the main line. What about this function, get the next token? Well, I figured that I would write that for you. So here's an example. There's an example of it running. But I first want to talk about the next token. Next token is a void function, but it sends back information in the parameters, the arguments. One thing it sends back always is the type of token it found. it's either an N for number, a P for operator, or an E for this is the end of the whole thing. Now, if it's N, I will send back the number in another parameter, which is called token I. If it's P, I'll send back the operator in another parameter, token C. Now, originally the C was for character. I am defining a class MyStack, and it uses something you may never have seen before. I don't remember if I taught it in 103, and I wouldn't be surprised if others hadn't. If you look here, that's the. I'll look at the program first. Here is the class. It's the same class I had in the other example, but it does not have int here or char. Instead, it has T. T is just the name. It says that in this class, T is going to be filled in later. It will be a type name. It will be int, char, string, double, something like that. But I'm not taking a stand when I'm writing the class because I want to use this for any kind of stack. The template comes before the class, and you use the word type name. Template and type name are reserved words. They have to be there. The T can be any variable. Now that means that everywhere I put char before, I put T. So you see I have a vector of T. Push a variable X of type T. I think that was the only place I had to do it. No, top. Top returns a variable of type T. So that means that in the program, you will declare a MyStack int. Int will take the place of T. That's it. That's what it will do. This is the main line. You are going to fill in two places, here and the else place. You're looking at the possibility that you have a number. Then you got to decide what you do with the number. That's only like one line. The else, you've got to decide what you do with an operator. That's more than one line. Because remember, in the algorithm, I said you had to get the top two elements of the stack. You had to do some arithmetic. You had to push things. You had to pop some things off the stack. You had to push back things. So there's maybe 4 or 5 lines there. The get token is here if you want to see it. It wasn't that difficult, but I did make a few mistakes as I usually do, and had to work on it. This is how I produced the number, and if you notice, this is how I made sure I had numeric elements, so that it was easy to work with. And those are the things I did. As I said, the two things you have to do is fill in those two sections. Now, here's an example of the program working. I filled in the pieces before I ran this. I'm passing in 91.7 plus 18.3 plus divide 6 multiply. You must put spaces between all the tokens. That's how I'm recognizing the tokens. Stack is empty. Next stack, it has 91 in it. Next stack, it has 91 and 7 in it. I am actually writing out the stack several times. I write it in the main, I think it's my stack P list somewhere. It must be, here it is, print stack. So I'm doing that so I can watch it. You can take that out if you want. I don't particularly care. But now let's look at what's happened. 91 and 7 were numbers. They went into the stack. The next token was plus. Plus says, take the 7 out, take the 91 out, add them together, and put the result back in the stack. Now you also have to pop the stack, so you get rid of those two things. I do a few pops. Now the next token is 18. I put that in the stack. The next token is 3. I put that in the stack. Then I come across a plus. So plus says, take the last two, 18 and 3, add them together, and after you get rid of the 18 and 3, put the 21 back in. So now I have in the stack 98, which was the result of the plus, and 21, which was the result of the other plus. Now it says do the division. Now you got to be very careful with the division, because what you want to do is divide 98 by 21. I made a mistake at first of dividing 21 by 98, but they're in this order. The 98's first, then the 21. So you have to divide 98 by 21. And when you do that, you get 4. Remember, we were doing integer division. Now I have a 4, and the next token is a 6. So I have the 4 and the 6. They're added together, and I get 24. The next token will come back as end, E. You'll end the while loop, and then you'll print out the value that is in the stack. Way down here at the end of the main line, you'll see, well, I guess I may have left that for you to fill in. I guess I did. You have to fill in the element to print the stack. No, I bet I didn't. No, I did. But that's easy enough to do. Now, this should not be a back-breaking homework. As usual, I'm willing to talk about it. We can set up Zoom sessions, or you can send me emails. I have scheduled it for 1 week from today, and I really don't want to get into the habit of constantly extending due dates. So please try to work on it. I realize you're under a lot of tension because of the problems on campus, and I hope that you can handle it. If you have problems with the homework, let me know. Okay? That's it. That takes care of an example for stack and a homework for stack. Converting from infix to postfix also uses stacks, but it's a little more complicated, and I'm not sure whether I'm going to give you that to work with or write it myself. We'll see what happens. The next step after stacks is queues, and we probably will get to those next week. So that's where we are. If you have any questions, let me know, and I'll see you later now. Bye.